variation to the ratio and proportion problem would be in similar figures. For example, I have two triangles. They are similar. Okay, so one small, one big. It's like a model versus an actual. Let's say that. Okay, this can be applied to a map problem as well, where your unit on the legend on the map is smaller than the actual unit. Okay, so let's say I have this triangle with the side here 10, this one is 5, I have here 8, and I want you to find out what this side is. Notice they are what we call similar. So that means 5 here is corresponding with the 10, and x here is corresponding with the 8. Okay, we talked about proportion before. When we set it up, we want to line it up the same way. This side is equivalent to that side. X here is corresponding to that one. So when we set up our proportion, guys, let's see, this one is going to be whatever you want to say. You want to call this first, so it's going to be x5. This one's going to be, if you're going to start with this length, you have to start with that length over here too. 8, 10. Okay, we set up our fraction that way. Once we have it set up, we can set them equal. Okay, notice 8 and x corresponding on top. 5 and 10 corresponding. They're both going to the bottom. Okay, you can't not mix and match. You can say, oh yeah, I'm going to take the 8 and match it up with the 5 and 10 with x. That won't work because this side is not the same as that side. They have to be the same. So notice 8 and x corresponding, 5 and 10 corresponding. Okay, but notice that everything from the small triangle has to be in the same side. Everything from the big triangle on the same side as well. So once we have it set up, we can cross multiply once again. So that's going to be 10 times x equals to 40 divided by 10 both sides. X is going to be 4. So that means this missing length is 4, which kind of makes sense. Notice that this is 5 times 2 is 10, 4 times 2 is 8. It has to make sense. Okay.